The S-hydrograph is used in order to derive a unit hydrograph with a different duration. Check the basics of this method here in hydrology. From the previous videos, when we derive a unit hydrograph, note that the examples such as the one presented contain a direct run of hydrograph with 2 hours intervals. Then we have converted this DRH into a unit hydrograph of the same interval, a 2-hour unit hydrograph. So to cut it short, a 2-hour DRH is provided and converted into a 2-hour unit hydrograph, or a 3-hour DRH was converted into a 3-hour UH. But how if what we have is a 3-hour DRH and what we needed is a 2-hour unit hydrograph? Are we just going to work on ratio and proportion? What is the S-curve? The S-hydrograph, which is also known as the S-curve, signifies a continuous effective rainfall at a constant rate for an infinite period. It actually looks like the letter S. To illustrate it, we start with a unit hydrograph, where at certain time intervals there are discharge coordinates. We term them right now as U's. These coordinates are used to derive the S-curve, using the cumulative unit hydrograph coordinates. This is like adding U1 to U2. Then, the succeeding coordinate consists of U3 with the accumulated previous coordinates U1 plus U2. The next coordinate adds the cumulative U1, U2, and U3 to U4. For the succeeding point, U5 has the cumulative U1, U2, U3, and U4. So basically, each coordinate takes the cumulative coordinates of the previous. Check that the end of the table creates a constant as shown in the graph. This is in contrast to the thinking that the values in the table should zero down. The first example provides a 2-hour unit hydrograph for a specific watershed, and we are to derive a 4-hour unit hydrograph using the S-curve method. The first thing to do is to create the S-curve of the 2-hour unit hydrograph. Start with 0 from T1, then add U2 to have 15 at T2. Add an X of 35, making 50 at T4. Then add 25 to have 75 at T6. And just the same, add 0 to have 75 at T8. If we are to continue the accumulation, we are like adding zeros, as there is no coordinates left from the unit hydrograph. We already attained the constant end of the S-curve. We have just completed the S-curve of the 2-hour UH. For us to generate the 4-hour S-curve, we have to lag the entries from S2. The provided unit hydrograph is 2, and since we are to look for the 4-hour unit hydrograph, we lag the S-curve by 4 hours. This means that the start of the non-zero entry of the S-curve is at T6. Then copy the rest of the coordinates. This is then the S-curve for the 4-hour unit hydrograph. After completing the two S-curves, we then take the difference. This difference hydrograph represents the direct runoff caused by continuous effective rainfall, lasting the desired duration. To keep it simple, we can say that the difference is the total direct runoff. At T0, the difference is 0. At T2 is 15. And at T4, the difference is 50. Then at T6, there is 75 minus 15 giving 60, followed by 75 less 50 or 25 at T8. The succeeding values remain 0 at T10, at T12, and also at T14. We have already completed the total direct runoff. The final step is to convert the DRH into unit hydrograph, and that is by dividing the DRH by the depth. However, it is difficult to identify how many centimeters we have lagged since we went direct to the required interval using the table alone. Just remember that we divide the factor taken as the desired UH duration upon the provided unit hydrograph duration. In this example, the desired UH duration is 4 hours, and what was given is 2 hours. The divisor then is 2. So, 0 is assigned at T0. Next is 15 over 2, which is 7.5 at T2. 50 over 2 or 25 is at T4, followed by 60 divided by 2 or 30 at T6. Next is half of 25, which is 12.5 at T8. Then, the rest is taken as 0, having a 0 DRH coordinate. We have derived the 4-hour unit hydrograph, where the peak discharge is 30 cumecs per centimeter at T6. Now let's recheck our answer using the method of superposition. 4-hour UH is a multiple of 2-hour unit hydrograph anyway. So from 2-hour unit hydrograph, lag the next UH a step lower. Note that the first non-zero entry is now at T4, so the lag stops here. Next is to take the summation, where at T0, DRH is 0. At T2, we have 15. 35 plus 15 or 50 at T4. 25 plus 35, which is 60 at T6. Then 25 at T8 and 0 at T10. Having a DRH, we determine the unit hydrograph by dividing direct runoff hydrograph with the depth. From the lags, we can easily identify that the effective rainfall depth is 2 centimeters, which we use to divide the DRH. T2 is still 0, but 15 over 2 is 7.5 at T2. 50 over 2 or 25 at T4. Half of 60 is 30 at T6. Then 25 upon 2 is 12.5. Then 0 at T10. We arrive at the same 4-hour UH values from the previous method. One might think that superposition is way easier than S-curve. It is. However, this method is limited to multiples of unit hydrograph durations. We discuss the advantage of S-curve in the next videos. For your practice, a 2-hour unit hydrograph is provided and you are to derive a 6-hour unit hydrograph. Follow the process and if done properly, you should have a peak discharge at T8 of 24.3 cumecs per centimeter. Good luck!